Greeting guys, so welcome back to our channel. So today I will be walking you through a notebook that demonstrates how to build a multimodal retrieval system using BG text embedding and clip image embedding for Wikipedia articles. So let's dive in. Alright, so let's start with a quick overview of what we will be doing. So we are using llamaindex to create a multimodal retrieval system. So this system will index text and images from Wikipedia articles, and then we will be able to query it using either text or image input to retrieve the relevant information. So for the first time, what we gonna do is we have to install a set of libraries. So make sure that you have the following packages installed, like llamaindex 50 and regex and pqdm, and then quadrant client, as we're gonna use quadrant for as a vector database, and torch vision, like matplotlib, and then scikit-image. So if you haven't installed these libraries in your environment, and try to install it. So yeah, let me do with you as well. So it just started to download the packages. So now it's done. So I have installed all the libraries that we need to run this notebook. So once it's done, our next step would be like we need to download the Wikipedia data. And what we're going to do is we will download the text and images for some of the Wikipedia articles. For this example, we will be using the articles of Batman, Pablo Picasso, and France, Tesla, and then BTS. So you can just change as per your need, and yeah, you can do your test as well. So what this code will do is it will fetch the text content of the specified Wikipedia pages that we have mentioned and save them into the local directory. So let's check. Okay, so here we have added like set of Wikipedia titles, and for each titles will be request get its pages, and once we got the pages, and we have to like extract it and then put it in a text file here with the name of the title as here for each, and we will be saving it. So let's run this cell. So as I have mentioned, like it just saved the all the title files here. Okay, for example, we can open and see, maybe, yeah, these are the text it just extracted from the Wikipedia. So yeah, so the next step would be like we're gonna download all the images for the corresponding topics. Okay, because we're gonna do like multimodal retrieval, where we'll be just extracting or like retrieving the text along with its images. Okay, now for to download the images, let's just try to mention all the titles that as we have mentioned in the previous cell. And what we will do is we will save each image with its unique identifier. So the segment of the code that you see here, what it will do is it can just download the images, and it limits the number of images per articles to avoid like overloading of our storage. Okay, and if you see here, we are limiting the number of image download per Wikipedia page, I mean, which is limited to 15. Okay, and we will be just downloading the images for these topics, and yeah, we will be just downloading the JPG and PNG format images and we will be saving it in the local directory here. So let's run this cell. Okay, we are getting some error like import Wikipedia, which is failed. So I think we have to install a package. Okay, let me install Wikipedia. Okay, sorry for the inconvenience here. Okay, so it's done now. Let me retry the same code to download the images for our Wikipedia titles. So as you see here, the images are populating here. So now it's done. We can just try to open and see what images have been downloaded. So great. So we have few set of sample images and text for to start our multi-modal retrieval system. Okay. So the next step would be, let me close all these windows here. So we will be using the Qtrend, as I said, to build our vector store for text and image embeddings. So we are using BGE English text embedding, and then we will be using clip embedding for the image side. So this is the llamaindex code for to set up our vector store and then create a multimodal index from downloaded Wikipedia data. So I have already imported the all the classes that we need to run our for to set up our vector database. So here if you see, we have assigned the model text embedding and then model for image embedding, and then we just initiated our Qt client, and then we will be just creating two set of collection. One is for text and the another one is for image, and then we will be just declaring the storage context for that. And once it's done, we will be importing all the Wikipedia data which are so all the Wikipedia data which are here in the data wiki, and once it's loaded, we're gonna just create a indexing database for this data. Okay, using the storage context as we defined here. So let me run this cell. Okay, we are missing out the library here. Again, sorry for the inconvenience, and yeah, let me do pip install. So it's done. Let me rerun the cell. So it just started to download these embedding models. So let me rerun the cell. Okay, QB is already exist here. Let me check. Yeah. So let me delete the folder here. Okay. So let me refresh. Okay, let me try with another name for our vector database. You can also just use the OpenAI API key to use the OpenAI embeddings. But for for me, the goal of the tutorial is to just simplify the overall usage using the open source models. So it just started to like push the embeddings to the pattern database. So now it's done. So your image collection is here and your text collection is here. Your vector DB is here. So now we have successfully downloaded the data from the Wikipedia and just embedded it and just stored it in our vector database. So let's like visualize some of the downloaded images to make sure that everything is working fine. Okay. For example, so this piece of code, what it will do is it will plot the images that we have downloaded. Okay. So let me run it. So image metadata dictionary is nothing but here, like let me search for it. Yeah, so it just populated from here in our image downloading cell. So this is completely an additional step to make sure like to visualize the images that we have downloaded or like corresponding to the topics that we have mentioned earlier. So yes, so now all set, like what we gonna do is we will try to build a separate clip image embedding index under a different like collection, which is Wikipedia image. Okay. So now everything is set. Like now we're gonna run our query and we're gonna test it. Okay. So let's run some of the example queries to retrieve information from our like multi-modal index, and we will use like both text and image queries to like demonstrate the retrieval capabilities. For that we need this utility function to plot the images that we have retrieved from our vector index. So yeah, so I have already ran it, and now it's time to visualize our result. Okay, ask a question and then retrieve the result from the vector db and then try to like print it or to display it in the better way. Yeah, it looks much better, like yeah. So let me retrieve only like two images, which is enough though, with high similarity for sure. It will be like 0.83 and 0.82, like yeah. So next question will be about Tesla. Yeah, it's amazing. So next question would be about the Batman and try to visualize the best result that we get. Yeah, it works like super fine here. Just retrieved all the Batman comic images. So we have run a similar queries for like the topics that we have like mentioned earlier for Pablo Picasso, famous paintings, and then for popular tourist place in the France and then more. It's not like really perfect, as we can maybe try with OpenAI embedding as well to get the best out of it. Um, and yeah, for the sake of simplicity, I used like the basic open source models, and yeah. So that's it. So we have now successfully built our like multi-modal retrieval system using BG and clip embedding. So you can try expanding this with more data or like different embeddings as well to see how it performs well. And yeah, that's it for today. Like, thanks for watching, and don't forget to like, subscribe, and hit the bell icon for more tutorials like this. And see you. Bye.